Hi guys. So this week we're going to be learning about ionic, covalent, and metallic bonding, and then learning how those bonds create shapes like these, like molecular shapes. We're going to talk about that in a second. Why am I dressed like this? I'm trying to get my videos all done today, and forensics is doing decomposition and like how to tell identity from a skeleton. So I just decided to be festive and make a skeleton face. And since I'm trying to get my videos done, you get to see my skeleton face too. So here we go. All right, so for this video, it's just going to be the first worksheet, which is really easy. It's really short, and I'm actually giving you some of the answers right now. So this is actually several of the answers. So please watch it and then go get those answers correct. Okay, so it's over ionic, covalent, metallic bonding. To start, let me remind you what those things mean. Ionic means it's a metal with a non-metal. That's how I know. So how do I know that sodium chloride is an ionic bond? Is because sodium is a metal and chlorine is a non-metal. So a little quick reminder, how do you know if it's a metal or a non-metal? We have our periodic table. Okay, so this side all the way to the stair step, which isn't drawn in on this periodic table, but it's like around here is a stair step. So all the way across right here is metals. All of those are metals. And then just this corner, it's like here would be the little stair step going right here. No. All these in the corner are non-metals. So if you have a bond between something over here and something over here, that's an ionic bond, okay? Now, you will look at your notes for the rest of the characteristics of ionic bonding, but I'm going to give you a couple of them now. So here's another answer. So one of the properties of ionic bonds is they almost always make crystalline solids. So if you look at salt, that's what NaCl is, under a microscope, it's actually perfect cubes, like literally perfect little cute cubes. And that is very characteristic of an ionic bond. They make perfect crystal shapes. Okay. Next is a covalent bond. So a covalent bond is between a non-metal and a non-metal. Oh, I should have put molecular on here. I'm pretty sure your worksheet says covalent. It does. So back in, I don't know, how long ago was it? A little while back, we were learning about ionic and molecular. Covalent is molecular. The reason why we call it by its other name covalent in this unit is because we have metallic, and that'd be two M's, so it makes it a little confusing. So covalent is molecular. It was non-metal and non-metals, okay? Those two non-metals come, or more than two. This is an example of a very long compound, but it has C, which is carbon, hydrogen, carbon, oxygen, oxygen, hydrogen. So these things come together and make one big compound, but they're all non-metals. All of them are non-metals. So it's a covalent bond, or what we used to call a molecular bond. So again, to know that this was a covalent bonded thing, you'd go look, and if it's over here in the corner, carbon's over here, oxygen's over here. Now this is the tricky one that we sometimes forget. Hydrogen is over here with the metals, but it's the only one that's over here. And technically it is a non-metal. Think of it, hydrogen is a gas. It's definitely not a metal. So it is a non-metal like these. The only reason it's over here is because it has one valence electron, which we've kind of started to talk about that. Now, one of the answers, so not only is that an answer, it's covalent. What is a property of covalent bonds is that they're brittle. So sugar is a covalently bonded thing. It's kind of similar to that. And you think about sugar, you think about how you can like just crunch it up. It's really easy to crush up. It's very brittle. Okay. Next one, metallically bonded thing. So metallically bonded thing is like what the name suggests, it's all metals. It is a bond between multiple metals. So if you see anything that says alloy, that is automatically a metallic bond. Alloy means two metals that are bonded together. So this is between tin and lead, both of which are metals. So if they're both metals, it's a metallic bond. The properties of metallic bonds are the same properties that metals have because it's just two metals bonded together. So they have the same metallic properties. So ductile, malleable, like conductor, like all those kind of things are still true then because they're just all metals. Okay, and that is it for the three types of bonds. You have to tell them apart. You just look at your notes for the rest to see what kind of properties belong to each one. Very simple.